Hello everyone. In this video I would like to share with you how to set up different position control options for the XL430-W250. So the task code I'm going to show you it shows how to set up different position control options by setting up different parameters. Something called operating mode, drive mode, velocity limit, profile velocity, and profile acceleration. So let's look at the robot that we plan to do the demonstration on. ROBOTIS Engineer Kit have something called SimpleBot, and it's actually the same thing, but instead of using this two simple frame, I add the arms to it, make it look neater. So ID 1 and 2 are over here, or shall we say the right arm, the right shoulder, and the right elbow, shall we say. And ID 3 and 4 is the left shoulder and left elbow. So let's first look at the control table for the 2XL430W250-T. So you see this is a screenshot from the manager tool. And first we want to look at the area, EEPROM area. And the EEPROM area, you have to watch out. You have to set up torque off to set the values, and you set a torque on to save them. Like if you want to change drive mode, operating mode, velocity limit, that's a procedure I have to do over here. And also you have to watch out is when this little button or field say torque enable on, it really means that the torque is off. So these are choices that you would like to make, not the current state of the control table. Okay, all right, so operating mode, address 11, this used to call control mode, and you have it 1, and that's used to call wheel mode, but now it's called velocity control mode. And if you set 3 to it, you're enjoying mode, that's the old name. The new name, position control mode. So that's for operating mode. So this is kind of equivalent to the old something called control mode. Drive mode is new, address 10. If you put 0 to it, it's it's in the normal mode. That means position control or position value are positive if you go counterclockwise. And also it's velocity based profile. We'll talk about these profile in a minute. These are very important, very neat those also. If you set it to 1, and then if you go counterclockwise, it will be negative values, or clockwise will be positive value. Either way, you see how you do it. Also, there's something called velocity limit. Address 44, I set up to 256. We'll see how it would impact position control or velocity control mode. Okay, next let's look at the RAM area. So in the RAM area, if you're already programming in tasks or something like that, usually we need to know goal velocity, profile acceleration, profile velocity, goal position. And because that in the RAM parameters, you can set these values anytime inside your task code, and we'll be okay. Now, goal velocity, address 104, you can see it is set up to 256, which is by default equal to the velocity limit. And goal velocity is used with velocity control mode only. So in the old control mode, in the old modules and stuff like that, they used to go something called moving speed or even goal velocity, depending on how old your servo are. And it used to be interchangeably. You can use it velocity control mode, or you can use it in position control mode. But with this new servo 2X430W250, you have to remember that goal velocity is strictly used with velocity control mode only, or in other words, wheel mode only. Okay, position control mode. There's several position control mode that you can set up, you can use. This is position control mode 1, where the profile velocity is 0 and the profile acceleration is set to 0. Of course, these are setting for individual servo motor that you can set. So in this case here, it's also called the step velocity profile, or the pulse if you want to. We're mathematics speaking that now. When you want to change the position from where you are to where you want to be for the servo motor, mathematically you send an infinite magnitude pulse to it, and it will achieve that change in position instantaneously. Okay, and that was only the mathematical realms. In reality, basically you pull up full power, that is much current voltage you can get into the motor without burning it, and it will try to get there. So in reality, it probably won't get these sharp edges, but probably smooth out, and then it won't be perfectly vertical up. It may be slightly slanted at an angle a little bit, and then smooth out to do here. So basically this situation here, you want to set up this mode, is when you want to change your position as fast as you can, as physically fast as possible, that the 2XL430 can do it. Okay. The thing is, it's always a very high current and lots of vibration involved, because it suddenly starts, suddenly stops. So it's actually not a very good mode to use your servo. The position control mode 2 is you give a profile velocity of some kind of number, non-zero, but you keep the profile acceleration to 0. In this case, this is so-called the rectangular velocity profile, or rectangular profile. So now, if, for example, in this case, I set up the profile velocity parameter to 125, and you can see the rectangle form. So the 125 will be the maximum velocity that you're going to get to. So you can see that the servo motor turn the velocity to 125 in the rectangular shape. Because the velocity constant, you can see that the change in position is linear. So that's where it starts, where it ends, and where it get to the point where it needs to go, velocity goes down straight. Okay. Next mode is mode 3, where both profile velocity and profile acceleration are non-zero. So this one is so-called the trapezoidal velocity profile. Okay, you can see it's trapezoidal shape here. So in this particular case, in my example of this video, I set up profile acceleration to 25, profile velocity 125. So you can see the acceleration profile will be here. So this 25, so it has rectangular shape. So this is doing the acceleration phase. And because it's constant, you can see that the velocity will increase linearly up into whatever you set up for the profile velocity, which is 1 to 25. And then you see acceleration is off, is 0. So the servo coasting at constant speed. And then up to certain T1, T2, the motor is apply a brake, shall we say, decelerate until it reaches the position where you want to go. So you can see it's the acceleration is in the other direction now, or deceleration. And that's why I can tell the trapezoidal acceleration deceleration phase is going to be symmetrical. I don't think you can change to have a different slope for the profile acceleration, unless you get into really fancy programming where you have to monitor the position trajectory to know where certain things are, so you can change the profile acceleration to a different value when it's coming down. I guess that is a possibility. Let's go through the example code. In the example code, the main thing is I call an initial position, an initial pose, and then I have an endless loop where I have pose 1, delay 2 seconds for it to get there, call pose 2, delay 2 seconds for it to get there, call pose 3, and delay 2 seconds for it to get there, and then the endless loop keep on going. Okay? The first run that we're going to do is all the profile velocity and all the profile acceleration are set to 0. So this is a so-called infinite velocity or step velocity there. Let's see what the video will show here. So that position is pose 2, pose 3, pose 1, pose 2, pose 3, pose 1. So you can see it go from one pose to the other one is pretty fast. That's as fast as it can do. So next is I put in profile velocity. All this profile acceleration is still 0. I put in the profile velocity. The profile velocity 1, servo 1, servo 3, I set it to 75, which basically corresponds to the shoulder. This is the right shoulder, left shoulder. And then ID2 and ID4, I set the profile velocity faster to 125, which is essentially the right elbow for 2 and the left elbow for 4. Okay, so these are rectangular velocity profile on all the servos. Let's see how they behave. So going 1 to 2, because it's using only the elbow, you see they're matching up. But if you look carefully now, when you go to 3, you see the shoulder legs behind because it's set up at 75 and not at 125. So the elbow I set to 125, you can see. Shoulder I set 75. Okay, next one is servo 1 and 2 profile acceleration. I set it to 25. Okay, so that means on the right arm I'm using trapezoidal velocity, but on the left arm, which is 3 and 4, I still have rectangular velocity profile. Okay, and everything still have delay at 2 seconds between poses. Let's see how it works. You see, because of the acceleration, you see the right arm is, shall we say, lazy right arm. It lags behind all the time. Position 1, position 3, pose 3, pose 1. So in this one here is we still have the lazy right arm setting, but now right after I send it to pose 2, instead of delaying 2 seconds, I delay only 100 milliseconds, and then I call pose 3. Essentially, in a way, I'm overriding pose 2. I won't let it go there to where it's supposed to go because I sent it away to another pose already. Okay. Here we go. 1. See, 1. It's supposed to go to 2, but it goes to 2 only a little bit, and it gets sent away to 3. Now, if you use servo motor before, like X12, X18, XL430, this you not to be able to do at all. And when you program the other one, and you can see how it's changing smoothly. So this is kind of important because let's suppose you think about it. Are you sending it pose 2, but some of your sensors send up some kind of signal where you really need to go to pose 3. So wherever you happen to be not finished pose 2 yet, you need to go pose 3. So now with the 2XL430, you can do those kind of options or those kind of programming situations very nicely. Next is I put back. Right after pose 2, I have 2 seconds again. So basically, pose 1 and pose 2 will be, you can see it will be defined clearly. And I call pose 3. It's trying to go to pose 3, but I delay only 250 milliseconds now instead of 2 seconds. And you can see the situation. You probably know what about to happen already. That 2. Okay, 1, 2. It gets sent to 3 for a little bit, and then immediately gets sent to 1, 2. Almost 3, down. Go to 2, send to 3, back to 1.